Circuit breakers from big box stores like Home Depot or Lowe's tend to be found in the off position, while those from electrical supply houses are often found in the trip position. There are a few possible reasons for this difference. Firstly, factory testing. Circuit breakers are typically tested at the factory before they are shipped. During this testing, the breakers are tripped to ensure that they function properly. It is possible that the breakers from electrical supply houses have been tested more recently than those from big box stores, which is why they are found in the trip position. Secondly, storage and handling. Circuit breakers can be sensitive to rough handling and storage conditions. Breakers that are stored in a humid or dusty environment may be more likely to trip during shipping and handling. This could explain why breakers from big box stores, which may have been exposed to more variable conditions, are found in the off position more often. Thirdly, resale of returned items. It is possible that some of the breakers found in big box stores are returns that have been resold. If a customer returns a breaker that they have previously tripped, it is possible that the store will put it back on the shelf without resetting it. This could also contribute to the higher frequency of off breakers found in big box stores. Fourthly, store policy. Some big box stores may have a policy of keeping breakers in the off position to prevent customers from installing them incorrectly. This is because a trip breaker will not allow electricity to flow, which could help to prevent accidents. It is important to note that the position of a breaker does not necessarily indicate its functionality. It is always a good practice to test a breaker before installing it to ensure that it is working properly. Testing a circuit breaker involves verifying its ability to trip under overload and short circuit conditions, as well as confirming its continuity when in the on position. There are several methods to test a circuit breaker, ranging from simple visual inspections to more sophisticated electrical tests. One simple method is a visual inspection. Before conducting any electrical tests, visually inspect the circuit breaker for any signs of damage such as cracks, burns, or loose connections. A damaged breaker should be replaced immediately. Next is the continuity test. Using a multimeter set to the continuity setting, check the continuity of the breaker when it is in the on position. The multimeter should indicate a low resistance, indicating that the breaker is allowing current to flow. If the multimeter indicates a high resistance or no continuity, the breaker may be faulty. After that, you will do an insulation resistance test. Use a megometer, also known as a megger, to measure the insulation resistance of the breaker. This test applies a high voltage to the breaker and measures the amount of current that leaks through the insulation. A low insulation resistance indicates that the breaker's insulation is compromised and that it should be replaced. Then you perform an overload test. This test simulates an overload condition to verify that the breaker trips within its specified time frame. To perform this test, you will need a variable power supply and a load resistor. Connect the breaker to the power supply and gradually increase the current until it exceeds the breaker's rated current. The breaker should trip within its specified time frame, which is typically a few seconds. A short circuit test is next. This test simulates a short circuit condition to verify that the breaker trips instantaneously. To perform this test, you will need a high current power supply and a short circuit test fixture. Connect the breaker to the power supply and apply a short circuit current. The breaker should trip instantaneously, typically within a few milliseconds. You can also use a breaker tester. There are several commercially available breaker testers that can perform a variety of tests on circuit breakers, including continuity, insulation resistance, overload, and short circuit tests. These testers typically provide a pass or fail indication, making it easy to determine whether the breaker is functioning properly. The frequency of circuit breaker testing depends on the application and the environment in which the breakers are used. In general, circuit breakers should be tested at least once a year in residential applications and more frequently in commercial or industrial applications. Breakers that are exposed to harsh environments, such as those with high humidity or dust, should be tested more frequently. Testing circuit breakers is an important part of electrical safety. By regularly testing circuit breakers, you can ensure that they are functioning properly and that they will protect your electrical system from overloads and short circuits. When testing a circuit breaker, always follow safe electrical practices. Wear appropriate personal protective equipment such as safety glasses and gloves. Ensure that the power is turned off to the circuit breaker before performing any tests. If you are not comfortable performing these tests yourself, contact a qualified electrician. Circuit breakers are designed to protect electrical circuits from damage caused by overload or short circuits. They are an essential safety device in any electrical system. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then must be replaced, a circuit breaker can be reset either manually or automatically to resume normal operation. Circuit breakers are made in varying sizes, from small devices that protect individual household appliances up to large switchgear designed to protect high-voltage circuits feeding an entire city. All circuit breakers have common features, regardless of their size or complexity. These include firstly, a frame. This is the structural support for the circuit breaker's components, typically made of molded plastic or metal. Secondly, contacts. These are the conductive parts that make or break the electrical circuit. They are typically made of copper or a copper alloy. Thirdly, an operating mechanism. This mechanism opens and closes the contacts, either manually or automatically in response to a fault. Fourthly, a tripping mechanism. This mechanism senses overcurrent or short circuit conditions and triggers the operating mechanism to open the contacts. Fifthly, an arc extinguishing device. This device helps to extinguish the arc that forms when the contacts open, preventing damage to the breaker and surrounding equipment. There are several different types of circuit breakers, each designed for specific applications. These include firstly, thermal-magnetic circuit breakers. These are the most common type of circuit breaker used in residential, commercial, and industrial applications. They use a bimetallic strip to sense overcurrent conditions and a magnetic coil to sense short circuit conditions. Secondly, magnetic circuit breakers. These circuit breakers use only a magnetic coil to sense both overcurrent and short circuit conditions. They are typically used in applications where fast tripping is required, such as in electronic circuits. Thirdly, solid-state circuit breakers. These circuit breakers use electronic components to sense overcurrent and short circuit conditions. They offer more precise and reliable protection than thermal magnetic or magnetic circuit breakers. Fourthly, high-voltage circuit breakers. These circuit breakers are designed to protect high-voltage circuits, typically above 1000 volts. They use a variety of technologies to interrupt the high-voltage current, such as oil, gas, or vacuum. Circuit breakers are rated by their voltage, current, and interrupting capacity. The voltage rating is the maximum voltage that the breaker can safely interrupt. The current rating is the maximum current that the breaker can carry continuously without tripping. The interrupting capacity is the maximum fault current that the breaker can safely interrupt. When selecting a circuit breaker for a specific application, it is important to consider the voltage, current, and interrupting capacity of the breaker, as well as the type of load being protected. It is also important to select a breaker that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or UL. Circuit breakers are an essential safety device in any electrical system. By properly selecting and installing circuit breakers, you can protect your electrical system from damage and prevent electrical fires. Regular inspection and testing of circuit breakers are important to ensure that they are functioning properly. Circuit breakers should be inspected for any signs of damage, such as cracks, burns, or loose connections. They should also be tested periodically to verify that they trip under overload and short circuit conditions. If a circuit breaker fails to trip under overload or short circuit conditions, it should be replaced immediately. The National Electrical Code, or NEC, provides detailed requirements for the installation and maintenance of circuit breakers. It is important to follow these requirements to ensure the safety of your electrical system. Article 240 of the NEC covers overcurrent protection, including circuit breakers and fuses. This article provides requirements for the selection, installation, and protection of overcurrent devices. Some key sections in Article 240 include firstly 240.4 Protection of conductors. This section specifies the requirements for protecting conductors from overcurrent. The general rule is that conductors must be protected at their ampacity, which is the maximum current that the conductor can carry continuously without exceeding its temperature rating. Secondly, 240.6 Standard ampere ratings. This section lists the standard ampere ratings for fuses and circuit breakers. Overcurrent devices are typically available in standard ampere ratings such as 15 amps, 20 amps, 30 amps, and so on. Thirdly, 240.21 Location in circuit. This section specifies the requirements for locating overcurrent devices in a circuit. Overcurrent devices must be located at the point where the conductors receive their supply. Fourthly, 240.24 Accessibility. This section requires that overcurrent devices be readily accessible. This means that they must be located in a place where they can be easily reached without having to climb over or remove obstacles. Fifthly, 240.40 Circuit breaker connection to terminals. This section specifies the requirements for connecting circuit breakers to terminals. Circuit breakers must be connected to terminals in a way that provides a good electrical connection and prevents overheating. Sixthly, 240.80 Method of operation. This section requires that circuit breakers be capable of being manually opened and closed. This allows for easy disconnection of the circuit for maintenance or troubleshooting. Seventhly, 240.81 Indicating. This section requires that circuit breakers clearly indicate whether they are in the on or off position. This helps to prevent accidental energizing of the circuit. Eighthly, 240.83 Marking. This section specifies the requirements for marking circuit breakers. Circuit breakers must be marked with their ampere rating, voltage rating, interrupting capacity, and other relevant information. These markings help to ensure that the correct breaker is selected for the application. Ninthly, 240.85 Applications. This section specifies the applications for which circuit breakers are permitted to be used. Circuit breakers are permitted to be used for a variety of applications, including protecting conductors, appliances, and equipment. Tenthly, 240.86 Series ratings. This section specifies the requirements for series ratings. Series ratings are used when two or more overcurrent devices are connected in series. The series rating is the maximum fault current that the combination of overcurrent devices can safely interrupt. In addition to Article 240, other articles in the NEC also address circuit breakers. For example, Article 408 covers switchboards and panel boards, which are commonly used to house circuit breakers. Article 430 covers motors and motor circuits, which often require special overcurrent protection. When working with circuit breakers, it is important to follow all applicable requirements in the NEC. This will help to ensure the safety of your electrical system and prevent electrical fires. Always consult with a qualified electrician if you have any questions about circuit breakers or other electrical equipment. They can provide guidance on selecting, installing, and maintaining circuit breakers in accordance with the NEC and other applicable codes and standards. The interrupting rating of a circuit breaker is the maximum fault current that the breaker can safely interrupt without being damaged. It is typically expressed in thousands of amps or kA. The interrupting rating of a circuit breaker must be sufficient to interrupt the maximum fault current that is available at the point of installation. The available fault current is the amount of current that would flow in a short circuit condition. It depends on the voltage of the electrical system, the impedance of the conductors, and the capacity of the power source. To determine the available fault current, you can use a fault current calculator or consult with a qualified electrical engineer. If the interrupting rating of a circuit breaker is less than the available fault current, the breaker could fail to interrupt the fault, resulting in damage to the breaker, the electrical system, and surrounding equipment. In some cases, a breaker with an insufficient interrupting rating could even explode, causing serious injury or death. To ensure that the interrupting rating of a circuit breaker is sufficient, it is important to perform a fault current study. A fault current study is an engineering analysis that calculates the available fault current at various points in the electrical system. The results of the fault current study can be used to select circuit breakers with appropriate interrupting ratings. The NEC requires that circuit breakers have sufficient interrupting ratings for the available fault current. Section 110.9 of the NEC states that equipment intended to interrupt current at fault level shall have an interrupting rating sufficient for the nominal circuit voltage and the current that is available at the line terminals of the equipment. In addition to the interrupting rating, circuit breakers also have a withstand rating. The withstand rating is the maximum fault current that the breaker can withstand for a specified period of time without being damaged. The withstand rating is typically expressed in amps. The withstand rating of a circuit breaker is important for applications where the breaker may be subjected to high fault currents for a short period of time, such as in motor starting circuits. When selecting a circuit breaker, it is important to consider both the interrupting rating and the withstand rating. The interrupting rating must be sufficient to interrupt the maximum fault current, and the withstand rating must be sufficient to withstand the high fault currents that may occur during normal operation. Circuit breakers are an essential safety device in any electrical system. By properly selecting and installing circuit breakers with appropriate interrupting ratings and withstand ratings, you can protect your electrical system from damage and prevent electrical fires. Always consult with a qualified electrician or electrical engineer if you have any questions about circuit breakers or fault current calculations. They can provide guidance on selecting, installing, and maintaining circuit breakers in accordance with the NEC and other applicable codes and standards. Proper installation and maintenance are crucial for ensuring the reliable operation of circuit breakers. Incorrect installation or inadequate maintenance can lead to premature failure, posing safety hazards and disrupting electrical service. Key aspects of circuit breaker installation include: firstly, proper selection. Choose circuit breakers with appropriate voltage, current, and interrupting ratings for the specific application. Consider the load characteristics and potential fault currents to ensure adequate protection. Secondly, secure mounting. Mount circuit breakers securely in a panel board or enclosure. Ensure that the breakers are properly aligned and supported to prevent vibration or movement. Thirdly, correct wiring. Use appropriately sized conductors for the circuit breaker's current rating. Make sure that all connections are clean, tight, and properly torqued according to the manufacturer's specifications. Fourthly, proper labeling. Label each circuit breaker clearly to indicate the circuit it protects. This helps with troubleshooting and prevents accidental disconnection of critical circuits. Routine maintenance is essential for extending the lifespan and ensuring the reliable operation of circuit breakers. Recommended maintenance practices include: firstly, regular inspection. Inspect circuit breakers periodically for signs of damage such as cracks, corrosion, or overheating. Check for loose connections, damaged insulation, or any other abnormalities. Secondly, cleaning. Keep circuit breakers clean and free from dust, dirt, and debris. Use a soft brush or vacuum cleaner to remove any accumulated contaminants. Thirdly, tightening connections. Periodically tighten all connections to ensure they are secure. Loose connections can cause overheating, arcing, and eventual failure. Fourthly, testing. Test circuit breakers regularly to verify their proper operation. Use a circuit breaker tester to check the tripping characteristics and ensure that the breakers trip within a specified time frame. Fifthly, lubrication. Lubricate the moving parts of circuit breakers to prevent corrosion and ensure smooth operation. Use a lubricant specifically designed for electrical applications. Sixthly, replacement. Replace circuit breakers that show signs of damage or wear. Do not attempt to repair damaged breakers, as this can compromise their safety and reliability. When performing any maintenance on circuit breakers, always follow safe electrical practices. To energize the circuit before working on the breakers and use appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable performing these tasks yourself, contact a qualified electrician.